A star vanished from the night sky. No explosion, no flash of light. As if someone simply flipped a switch in the cosmos. It just went dark. That star was in the Andromeda Galaxy, our nearest galactic neighbor, 2.5 million light-years from Earth. For decades, it had been one of the brightest supergiants there. Then, in 2014, something strange began. The star suddenly brightened in mid-infrared wavelengths, as if burning one final flare. And starting in 2016, it began fading rapidly, dimmer and dimmer and dimmer. By 2022, when the Hubble Space Telescope turned its gaze, back to that spot, the star was already gone. Not visible in optical light, not in near-infrared, not in any wavelength. Its brightness had plummeted to 1/10,000th of what it once was. In the entire history of astronomy, no massive star had ever disappeared this quietly before. In February 2026, a paper was published in Science, Disappearance of a Massive Star in the Andromeda Galaxy, due to formation of a black hole. For the first time in human history, the birth of a black hole had been witnessed. To understand how a star dies, one must first understand how a star lives. Deep inside every star, nuclear fusion is at work. Hydrogen nuclei collide and merge into helium, releasing enormous energy that pushes outward. This is radiation pressure, the force that inflates a star. At the same time, the star's own mass generates gravity, pulling everything inward. Outward push from fusion energy, inward pull from gravity. This tug-of-war sustains a star for millions to billions of years. But nothing lasts forever. When hydrogen runs out, the star burns helium. When helium is spent, it moves to carbon, then neon, oxygen, silicon, layer upon layer, like the shells of an onion. Each element is consumed in turn, and then the star reaches the final element, iron. Iron cannot release energy through fusion. It absorbs energy instead. The moment iron accumulates at the star's core, it is a death sentence. There is no more outward force to push back. Gravity finally wins the tug-of-war, and in that instant, the core collapses. The heart of a star, 13 times the mass of our sun, crumbles inward in less than a single second. Normally, this is where a supernova occurs. When the core collapses, a neutron star forms at the center, city-sized yet heavier than the sun. During this birth, an enormous flood of neutrinos is released. Those neutrinos generate a shockwave, and that shockwave blasts the star's outer layers apart. This is a supernova explosion, one of the most violent events in the universe. A single exploding star releases as much energy as the sun would emit over 10 billion years, a brightness that briefly outshines an entire galaxy. In the aftermath, a neutron star remains, or if the progenitor was massive enough, a black hole forms. This is the textbook scenario. But in M31 2014 DS1, the textbook scenario did not play out. A shockwave was generated, yes, but it was not powerful enough to punch through the star's outer layers. The inward gravitational pull of the falling material overpowered the outward push of the neutrinos. The shockwave stalled midway and was sucked back inward. The explosion never happened. The supernova failed. Astronomers call this a failed supernova. The star died, but instead of a glorious final act, it chose silent oblivion. After the failed supernova, something entirely different unfolded inside the star. With the shockwave defeated, the outer material began falling back toward the center. Matter piled onto the neutron star, more and more and more. At some critical threshold, even the neutron star could no longer support its own weight. It collapsed, and in its place, an event horizon opened. A black hole was born, a stellar mass black hole of roughly 5 solar masses. But this birth was not violent. The energy released was 1,000 times weaker than a supernova. That is why the star did not explode, it simply vanished. The key mechanism here was convection. Inside a massive star, temperature differences are extreme. Billions of degrees at the core, thousands at the surface. This differential drives constant gas circulation. Hot gas rises, cool gas sinks a vast convective churning. When the core collapsed, this convecting gas did not plunge straight into the black hole. Its rotational momentum kept it orbiting, spiraling inward slowly, very slowly, like water swirling around a bathtub drain, rather than flowing straight down. In the process, only about 1% of the stellar envelope actually fell into the black hole. The rest was gently pushed outward at low velocity, forming a cooling shell of dust. That dust shell was the source of the 2014 infrared brightening, a theoretical prediction that had existed for 50 years. was observationally confirmed for the very first time. What makes this discovery extraordinary is the depth of the observational record. The lead astrophysicist at the Flatiron Institute began sifting through NASA's NEOWISE archive data in 2022. NEOWISE was an infrared space telescope that mapped the entire sky from 2009 to 2024. Within that vast data set, one star in the Andromeda Galaxy caught his eye, a star that had shone steadily for decades before 2014, then suddenly brightened in mid-infrared starting that year, and within barely a year after 2016, plummeted far below its original luminosity. When I saw it disappearing into darkness, I got goosebumps, but NEOWISE alone was not enough. The Andromeda Galaxy is one of the most popular targets in astronomy. This meant archives from numerous world-class telescopes were available. Hubble Space Telescope data from 2022, ground-based observations from the Keck Observatory in 2023, and in 2024, data from the James Webb Space Telescope and the Chandra X-ray Observatory. Infrared, visible light, ultraviolet X-rays, cross-verification across every wavelength. The results were consistent. The star was gone, and in its place, only a faint reddish dust blob remained. This was not a chance detection by a single telescope. More than a decade of multi-wavelength observations, all pointed to one conclusion. This star had become a black hole, but science does not end with a single interpretation. In January 2026, a paper was published in the monthly notices of the Royal Astronomical Society, reaching the exact opposite conclusion. A team from Liverpool John Moores University analyzed the same JWST and Chandra data and proposed an entirely different scenario, a stellar merger. Two stars orbiting each other, colliding, fusing into one. During this process, an enormous amount of dust is ejected, and the merged star becomes shrouded in a thick dust cocoon, appearing to have vanished. I want to confirm a failed supernova as much as anyone. But before we do, every other possible scenario that could cause a star to disappear must be ruled out first. This counterargument cannot be dismissed lightly. Dust is notoriously called the scoundrel's refuge in astronomy, because almost any set of strange observations can be explained by some carefully arranged configuration of dust. And this flexibility cuts both ways, so one decisive test remains. If it was a stellar merger, the dust will clear and the star will shine again. If it was a black hole, it will stay dark forever. Dust cannot obscure things forever. The expanding shell thins over time. The veil must eventually lift, but that could take decades, potentially outlasting the planned lifetime of JWST itself. The answer is not yet settled. The most dramatic event in the universe can happen in the most silent way. That is the greatest message of this discovery. When most people imagine the birth of a black hole, they picture a supernova explosion, a blinding flash that outshines an entire galaxy. But M31 2014 DS1 showed something different. A star can become a black hole without exploding, silently, without light, simply by vanishing. This matters for a profound reason. Astronomy has a long-standing mystery, the missing supernova problem. Based on the rate at which stars are born, more supernovae should be observed than actually are. Stars are dying somewhere out there, but their explosions are nowhere to be seen. M31 2014 DS1 may be part of the answer. A significant fraction of massive stars may be quietly transforming into black holes without ever producing a supernova. The Vera C, Rubin Observatory, and NASA's Nancy Grace Roman Space Telescope are soon set to begin large-scale searches for these quiet deaths. Within a few years, more vanishing stars will likely be found. Right now, at this very moment, somewhere in the night sky overhead, a star may be quietly disappearing. No explosion, no flash, leaving behind only darkness. And at the heart of that darkness, a black hole is being born.